a physical weighing machine, a thermometer which measures temperature. What is length? What is time which can be measured? Proceeding to few of the concepts, we have developed acceptable standards, acceptable references. Hello students, this is SDsir from the Temple of Excellence, Vidhyaashram PU College, Mysuru. Today again, shall we take a walk in the forest of fuses? Sure, I'll make things very interesting for you all. Physical world, physics is what we start discussing from today. My first chapter of discussion is units, measurements, and dimensions. My dear students, this is the most fundamental chapter, the most skeletal chapter you will be studying in physics. But although fundamental, although skeletal, it is an implication of our daily life activities. What do we study in this chapter? It is units, measurements, and dimensions. What is the significance of this chapter in my practical life? The moment I get down from my bed, I go to the vegetable vendor, ask him for 2 kgs of onions. I am measuring some mass. I look at the time, it is already 8 o'clock. I have to rush to my college. I am measuring time. I go inside the class. I feel hot. I set the temperature of the AC to 20 degrees Celsius. I measure temperature. So every walk of life surely is related to some type of measurement, and the first elementary thing I teach you all in this chapter is to measure physical quantities. Once I do some measurements, I am not very precise about my measurements, which means there may be some errors that might have crept in. So I will try to understand what is an error, what are the different classification of errors, and once I have understood things about errors, I will try to understand how to eliminate errors. And once I have known elimination techniques, I will try to understand how to report my result in terms of significant digits. So my dear students, in session 1, we will clearly try to understand what is measurements, what is units, and concepts related to them. Fine. Now, as you can see the slides, there is a weighing machine, a physical weighing machine. Kannadದಲ್ಲಿ takadi ಅಂತ ಕರಿತೀವಿ. There is a thermometer which measures temperature. There is a measuring tape which is basically used to measure length. So what is mass? What is temperature? What is length? What is time? Please to understand, they are all called as physical quantities, and therefore my first topic of understanding is something called as a physical quantity. Now, the textual definition says any quantity that can be measured is a physical quantity. If you are able to measure a quantity, then those quantities are termed as physical quantities, something related to the physical world. I go to the vegetable vendor, ask him for 2 kgs of onions. He'll take that physical balance, takdi. He will give me 2 kgs of onions. I have measured mass. So mass is a physical quantity. I go to a tailor, ask him to stitch 10 centimeter shirt for me. He measures 10 centimeters length. So length is measured. It is a physical quantity. What is the distance of the college from my house? 5 kilometers, 10 kilometers. Beautiful, distance is measured. So distance is a physical quantity. So my simplest understanding says any quantity which can be measured, all measurable quantities are physical quantities. Now, slightly upgrading my thought, I say these quantities are measured either directly or indirectly. My God, what is this? Direct measurement or indirect measurement? Go to the vegetable vendor, ask him for 2 kgs of tomatoes. He takes the physical balance, measures 2 kgs of tomatoes, gives it to you. So there is a direct method of measuring mass. Tomorrow morning, you go to the same vendor and ask him for 2 kgs of molecules, 2 kgs of atoms. He will say, boss, your place is somewhere in Bangalore. Why? Mass of atoms or molecules cannot be measured directly with a physical balance. I have got a technique called atomic mass unit which measures mass of atoms and molecules indirectly. So see the comparison, very beautiful. I can measure mass directly through defined devices. Sometimes mass is also measured indirectly through developed techniques. Distance, height. What is the distance of your house from the college? 5 kilometers, sir. What is the distance of Neptune from the college? How many meter scales will I use? So I have an indirect method of measuring large distances. Therefore, we say physical quantities can either be measured directly or indirectly. So putting them together, the basic definition for a physical quantity is any quantity that can be measured directly or indirectly, or all measurable quantities measured directly or indirectly are physical quantities. Example, area. Yes, I can measure area. It is a physical quantity. Length, mass, force, current, time, temperature. So any quantity which can be measured is a physical quantity. The other way now, do I have something called non-physical quantity? Do I have something which cannot be measured? Yes, can be measured. The love our parents show towards us, non-measurable. So it is non-physical. Suppose two girls become enemies, can you measure the amount of hatred they show? Absolutely no. So it is non-measurable, non-physical. But please to understand, physics has nothing to do with the non-physical world. We are only dealing with the physical world, and therefore we just concentrate on physical quantities. So what are physical quantities? Something which can be measured. Yes, they can be measured directly or they can be measured indirectly. Now, proceeding to few of the concepts related to measurements, few topics related to the measurements of physical quantities. The first thing or the first concept which is very important is unit. Right from your lower classes, frequent number of times you have heard this word unit. Now what is unit? That is what very clearly I will be discussing in today's session. Unit of a physical quantity. First, I consider measurement of mass an activity that is related to the measurement of mass. I go to the vendor, same vegetable vendor to whom I went yesterday morning, and I'll say, give me 5 centimeters of onion. He's buzzing at me. 5 centimeters of onions you want? Please go back home. I did not understand why I go back home. Next, my teacher is asking the distance of my house from the college, and I say the distance is 3 kgs. My teacher is puzzled. Dear student, what has happened to you? Your house is 3 kg far away from your college. My dear student, you require some counseling. My friend asks, what is the time by my watch? And I say, it is 4 degrees Celsius. My friend will never turn towards me now because I have expressed time in degrees Celsius. Pondering students, mass 5 centimeters. No sir, mass has to be measured in kgs. Who told that? I want to express in centimeters. So I say mass is 5 centimeters. No sir, universally it is accepted. Mass is 5 kgs. Length. Arey Baba, length I am measuring in kgs. What is bothering you? I don't want to follow the world. No, sir. Again, universally, length is measured in meters or centimeters. Time again is measured only in seconds or hours. So if you find here a very interesting sequence, you people don't accept the units which I follow to measure mass, length or time. You say mass has to be expressed in kgs. Fine, darling. Length in meters. Yes. Current in amperes. Fine. Force in Newton. Absolutely good. Which means there is a standard with which every physical quantity is measured or represented. Kg is the standard of representing mass. Therefore, I say, yes, mass has a unit called kilograms. Temperature has a standard representation of degree Celsius. Therefore, I say temperature has a unit called degree Celsius. The standard unit of representing velocity is meter per second. Therefore, the basic definition of unit says that it is a standard, a selected standard or reference with which a physical quantity is compared. We have developed acceptable standards, acceptable references to measure a physical quantity, and that is what is called unit of a physical quantity. So what is unit, my dear students? It is simply a standard, a chosen standard or reference with which a physical quantity is compared. Now, what are the characteristics of selecting a unit? Suppose mass. In India, I measure mass in kgs. In US, it is done in centimeters. In France, it is done in amperes. Do we accept? Leads to lot of confusions. If mass is measured in kgs in India, elsewhere in this globe, the same standard has to be used. Length na ಇಂಡಿಯಾದಲ್ಲಿ ಮೀಟರ್ ಅಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ರೆ ನಾವು ವಿಶ್ವದಲ್ಲಿ ಎಲ್ಲೇ ಹೋದ್ರೂ, ನೀವು ಅಮೆರಿಕಕ್ಕೆ ಹೋಗಿ, ರಷ್ಯಾಗೆ ಹೋಗಿ, ಪಾಕಿಸ್ತಾನ್ಗೆ ಹೋಗಿ, ಲೆಂತ್ ನ ಮೀಟರ್ಸ್ ಅಲ್ಲೇ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬೇಕು. ವಿಚ್ ಮೀನ್ಸ್ the unit should always be internationally accepted. ಇಡೀ ವಿಶ್ವದಲ್ಲಿ ಒಂದು ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿಗೆ ಕಾಮನ್ ಆಗಿರೋ ಯೂನಿಟ್ ಫಾಲೋ ಮಾಡಬೇಕು. ಸೊ ದಿ ಯೂನಿಟ್ ಐ ಸಿಲೆಕ್ಟ್ ಟು ರೆಪ್ರೆಸೆಂಟ್ a physical quantity should be internationally accepted and easily understood and easily reproduced. Andre easily reproduced andre, the moment I ask you What is the unit of force? Immediately you should say Newton. What is the unit of force? Newton, ampere. No, I am not getting this. You should not have that ambiguity, confusion irbardo. The moment I ask you the unit for velocity, meter per second. So any unit should be easily understood as well as easily reproduced. So what is a unit, students? It is a standard or chosen reference to compare a physical quantity. What are the three characteristics of a unit? It has to be internationally accepted, easily understood, and easily reproduced. Now, the next topic I discuss is magnitude. Probably now, wherever I use physics, I am very common with a term called as magnitude. Yenidu magnitude andre? No exaggerations. See, for example, I measure mass and I say mass is 5 kgs. Abba, we are all saved. Finally, sir has expressed mass in kgs. Good. What is this kg? Yes, we understood. It is the unit of referring mass. What is this 5? What, sir? What is this 5? 5 is just a number. Good kids. 5 is a number which is accompanying kg. How many kgs is the mass? 5 times, 10 times, 20 times. So this number which accompanies the unit of a quantity is called as magnitude. No exaggeration. ಯಾವುದೇ ಒಂದು ಯೂನಿಟ್ ನ ಅಕಂಪನಿ ಮಾಡೋ ಒಂದು ನಂಬರ್ನ ನಾವು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಅಂತ ಕರಿತೀವಿ. It is not like highlighting that word in bold letters, making it very, very superficial. No, simple in understanding. ಏನ್ ಮರಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಅಂದ್ರೆ ಅದೇ ಸರ್, ಒಂದು ಯೂನಿಟ್ ಜೊತೆ ಒಂದು ನಂಬರ್ ಪ್ರೆಸೆಂಟ್ ಇರುತ್ತಲ್ವಾ, ಆ ಯೂನಿಟ್ ಎಷ್ಟು ಟೈಮ್ಸ್ ಆ ನಂಬರ್ ಅಂತ ಹೇಳುತ್ತಲ್ವಾ, ಅದೇ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್. ಗುಡ್. ಫೋರ್ಸ್. ಮೆಸ್ಸಿ exerts 10 Newton force on the football. What is Newton? It is the unit of force. How much of force is exerted? 10 Newton. So what is 10? It is the number which is accompanying the unit called Newton. So 10 is the magnitude. So please to understand, magnitude is simply a number. It will define how many times the unit is repeated, and that number is called as magnitude. Now, this is a very important bookwork. Probably again a very simple understanding for your entrance. Write the mathematical relationship between magnitude and unit of a physical quantity. I have to write the mathematical relationship between magnitude and unit of a physical quantity. Again, for which I'll consider this example, which is measurement of mass and I say mass of an object is 10 kgs. Keep in mind, I am writing a relationship between magnitude and unit of a physical quantity. I have measured mass of a quantity and I am saying it is 10 kgs. Come on friends. What was mass? Ade sir, measurable quantity in helkotralla. Good. What is a measurable quantity? It is a physical quantity. What I represent as Q equals, what is 10? Sir, ನಾನು ಹೇಳ್ತೀನಿ ಏನಪ್ಪ, 10 is a number accompanying the unit called kg. Therefore, it is called magnitude. Very good. M ಅಂತ ಬರಿತೀನಿ. What was kg? Unit. The entire class is shouting unit. Beautiful. Now, I want a relationship between magnitude and unit. If I rearrange this, unit is physical quantity divided by magnitude. But I want the relation between U and M. So very clearly, U is inversely related to magnitude. High school alli odirtira direct relations, proportions, inversely related. So unit of a physical quantity is inversely related to magnitude. Andreno, as the magnitude of the measurement increases, unit decreases. How is it possible? Any logical answer? Yes, this is an assignment for you all. You don't get, I'll take up in the next session, but you have to think. I've given you a justification. Unit of any physical quantity is inversely related to magnitude. How? This is your justification. But remember, as the magnitude of a physical quantity increases, unit always decreases. Or if the magnitude decreases, unit always increases. Now, going to the classification of physical quantities. Beautiful slide where you can see a future Messi in presentation with the nabbing techniques, with the dribbling techniques of the football. How is it related to my physical quantities? Yes, we will do understand now. Classification or types of physical quantities. My dear students, understand there are two types of physical quantities. Physical quantities ಅನ್ನ ಎರಡು ಗ್ರೂಪ್ಗಳ ಕ್ಲಾಸಿಫೈ ಮಾಡ್ತೀವಿ, ಎರಡು ಟೈಪ್ಗಳ ಕ್ಲಾಸಿಫೈ ಮಾಡ್ತೀವಿ. ಒಂದನ್ನ ಫಂಡಮೆಂಟಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ಅಂತ ಬರಿತೀವಿ, ಇನ್ನೊಂದನ್ನ ಡಿರೈವ್ಡ್ ಕ್ವಾಂಟಿಟೀಸ್ ಅಂತ ಬರಿತೀವಿ. So my dear friends, which are the two types of physical quantities? One is called fundamental quantities and the other one is called derived quantities. Now, first let us try to understand what is a fundamental quantity. A fundamental quantity is also called base quantity. Fundamental, ವೆರಿ ಬೇಸಿಕ್. ಮನೆಗೆ ಅಡಿಪಾಯ ಹಾಕ್ತಾರಲ್ಲ, ಫೌಂಡೇಶನ್. ನಿಮಗೆ ಹೈಯರ್ ಸ್ಟಡೀಸ್ಗೆ ಈಗ ಫೌಂಡೇಶನ್ ಹಾಕ್ಕೊಡ್ತಿದ್ದೀವಲ್ಲ, ಅದೇ ರೀತಿ ಫಿಸಿಕ್ಸ್ನ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ ಯು ನೀಡ್ ಟು ನೋ ವಾಟ್ ಆರ್ ಫಂಡಮೆಂಟಲ್ ಕ್ವಾಂಟಿಟೀಸ್. My dear students, as I told, fundamental, they are very basic, they are very skeletal. So coming to the proper understanding of these quantities, the definition says they are independent of each other. They do not depend on each other. They have their own characteristics, and such quantities are called fundamental quantities. ಮೂರು ಟರ್ಮ್ಗಳನ್ನು ಯೂಸ್ ಮಾಡಿದ್ದೀನಿ ಇಲ್ಲಿ. They are base quantities. They are independent of each other. They don't depend on each other. They cannot be expressed in terms of other quantities. They are unique. What is the meaning of this? Now let me consider an example here. I'll consider two rods. This is a thicker rod and this is a thin rod. So I have considered an example where I have two rods, a thicker rod and a thin rod. Thicker rod will have more mass, whereas a thin rod will have less mass, but both of them have the same length. Although this may be thicker, although this may be thinner, but the feature is they have the same length. Interesting, follow Madi. It doesn't mean that if this rod has more mass, it should also have more length, or if this rod has less mass, it has less length. No, which means length is unique of itself. It cannot be expressed in terms of mass. It cannot be expressed in terms of time. It cannot be expressed in terms of temperature. So it is a fundamental quantity. The next example, I am 50 kg mass. Put me into this room, lock the room, start a clock. Clock is revolving, tick, 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 tick. 24 hours finished. Tomorrow you open the room, time has changed. The mass of sir is not changed. Why will it change? Mass doesn't depend upon time. So mass is a fundamental quantity, base quantity. You cannot express mass in terms of other quantities, and such quantities are called fundamental quantities. So what are fundamental quantities, friends? They are quantities which depend only on themselves. Whatever you do, you cannot express them in terms of other quantities. They are self-dependent base quantities. And the units expressed fundamental quantities are called fundamental units. Now, derived, the second class of fundamental quantities, derived quantities. What do you mean by derive? You are getting them from something. You are arriving at them. You are deriving them. So what are derived first quantities? These are quantities which is expressed in terms of fundamental quantities. Any quantities which are taken, which are derived, which are obtained from fundamental quantities, such quantities are called derived quantities. For example, area. Basically, I define area as length into length. My dear friends, length is a fundamental quantity, and I've got area from length. Density, mass divided by volume. Mass is a fundamental quantity. I have arrived at density using mass. So this is a derived quantity. Frequency, 1 by time, reciprocal of time. Time is a fundamental quantity. So any such quantities which you are getting by using fundamental quantities are called derived quantities. So what were fundamental quantities? Those were base quantities. Sir, you told they cannot be expressed in terms of other quantities. Sir, you told they do not depend on other quantities. But what is and derived quantity? Sir, any quantity that is obtained or got by using a fundamental quantity is a derived quantity. Now, here is a table which shows the 7 fundamental quantities with their standard unit and symbol. Length, the unit is meter, symbol is small m. Mass, kilogram, kgs. Time, unit is second. See, the symbol is not capital S. Here afterwards, strictly you have to follow this representation. Temperature, Kelvin, K. Current, unit is ampere, symbol is A. Amount of a substance, mole, MOL. Luminous intensity, candela. Remember, intensity, brightness of light, candela, symbol is CD. So I've given you an introduction to what we are doing in the next coming sessions. Now you have understood what is a physical quantity, what is unit, what is magnitude, the 2 classes of physical quantities and their units and symbols. Before I meet you all in the next session, I hope you are thorough with these concepts. Enjoy the concepts. Let us meet in the next session. Stay safe. Until then, thank you.